Okay, so now we're going to graph some parabolas or quadratic equations. Remember, quadratic equations graph to be parabola. That's a shape. And we gave you the shape equations in the first video we just did. So you want to make sure that you have these. Hopefully you have them on a sheet of paper so you can refer to them, because I'm not going to, just for the sake of time, I'm not going to do a table of values and put the numbers in for each problem, but you could do that on a quiz if you need to. But after a while, if you start memorizing these things, it'd make it a lot easier. So make sure you have this little work that we already did, the previous video, on hand, and then we'll be just using these particular relative moves to the vertex when we do these parabolas with different vertexes. All right, so let's take a look at some examples on graphing quadratic equations or parabolas in vertex form. And when we have a form like this, a f of x or y equals a times x minus h squared plus k. All right, this is a quadratic equation because we have a square term in it, and it graphs to be a parabola. And if we have it in this form, we can tell that the vertex is at h, k, and we notice that this is the this will be the horizontal shift, and this will be the vertical shift. And the horizontal shift is kind of the opposite sign of what's going on here. So if I've got negative h, it's going to be horizontal shift will be positive h, and the same sign for k. So we can think of this as opposite sign, same sign when we figure out the vertex, which it is actually the realization of the horizontal shift and the vertical shift. All right, let's take a look at this. So if we look at this first example, I see that the vertex is at 3, negative 2. Remember, opposite sign, same sign. And my shape equation is going to be the parabola without the shift. So just cover up the negative 3 and the negative 2, and all you have is x squared. So that's my shape equation, y equals x squared. And I use that shape that we just talked about in the previous video. So first of all, I'll put my vertex down. So that means 3, negative 2. So my vertex is normally here. So I have a horizontal shift of 3. That's 3 to the right and down 2. So there's my vertex. And then if I look at my shape equation, it's the same as x squared. So I'm going to go over 1, up 1, back 1, up 1, over 2, up 4, back 2, up 4, and there's your 5 points, and that's how quick you can do it. And make sure you mark those 5 points fairly significantly, because that's important, and then we just connect those and try to make sure that it kind of looks like a smooth curve. So I would say to make this look like a little bowl down here, like a breakfast bowl, and then connect it up. And you're just going to connect those 5 points, and there you go. There's your parabola. Pretty easy. And it's going to be shaped the same. It's going to be shaped the same as this parabola, x squared, except it's shifted over 3 units to the right and up 2 units, but it has the same shape. Okay, that's why the shape equation makes everything kind of easy. All right, let's take a look at the second example. Where's my vertex? Well, opposite sign, so it's going to be negative 1 and same sign 2. So that's my horizontal shift, 1 to the left, and vertical shift up 1. And then my shape equation will be everything without the shifts. So I take out the 1 and take out the 2, and all that's left is, you can kind of cover those up if you want. If you kind of cover those up, all that's left is y equals negative x squared. All right, so y equals negative x squared. So that's my shape equation. So I find my vertex. So my vertex will be at negative 1, 2. So there's my vertex. And then if I look at my shape equation for y equals negative x squared, I go over 1 and down 1, back 1 and down 1, over 2 and down 4, back 2 and down 4, and there's my 5 points. And then I can connect those with a smooth curve and make this look like kind of like the nose cone of a rocket, so it should be rounded, not pointed. And then bring it straight down like this, and straight down like that. And there you go, it's pretty easy. Okay, next vertex form is y equals 2x. It's over here. 2 times x plus 3 squared minus 4. So what's my vertex? So it's opposite sign, so it's going to be negative 3. Same sign, negative 4. So there's my vertex, negative 3, negative 4. And my shape equation, well, if I cover up the vertex, I just have 2x squared. So that's my shape equation. 2x squared, you can see that. So there's your shape equation, 2x squared. And then plot the vertex. So the vertex is going to be negative 3. So that's 3 to, that's the horizontal shift is 3 to the left, and the vertical shift is down 4. So there's my new vertex. And then relative to that, you look at your shape equation. This is my 0, 0, so I go over 1, up 2, if you look at your shape equation. Now again, you can refer to these, but this is the table of values you would use. 0, 0, over 1, up 2, back 1, up 2, over 2, up 8, back 2, up 8. So these are the table of values, just like these are the table of values I would use for my negative x squared shape. So the same values. That's a nice thing. So I go over 1, up 2, back 1, up 2, over 2, up 8, 2, 4, 6, 8, and to the left 2, up 8. Now we know these have an axis of symmetry right down the middle, so these would be symmetrical, so you can double check that. And then we can make this like a smooth curve, so this is kind of a deeper bowl, if we're going to use the bowl idea. And then connect these. And there you go. And again, this has the same shape as this parabola. It's just shifted to the left 3 and down 4. So it just moved over. But it has the same shape. That's why we call this the shape equation, minus 2x squared. Okay, let's take a look at the next one. And again, my vertex is going to be at opposite sign. So this is going to be a 2, same sign, 3. So there's my vertex. And my shape equation, it's just going to be negative 2x squared. All right? So the shape will look like this one that we did on our shape equation. So I would use this table of values if I was just doing this from scratch. So first of all, I'll find my vertex. So my vertex is at 2, 3, over 2, up 3. And that again represents a horizontal shift of 2 to the right and a vertical shift of up 3. And I'm going to use this shape equation. So if I look at these table of values, I go over 1, down 2, left 1, down 2, over 2, down 8, left 2, down 8. So I just find my points. So over 1, down 2, because it's negative, and left, down 2, over 2, down 8, 1, 2, 3, 4, 5, 6, 7, 8, and to the left 2, down 8. 3 and 5 makes 8. And I can sketch it. Now remember, it makes kind of sense that if we put a number in front, we're going to make it skinnier. All right? If the number is bigger than 1, if the number is less than 1, we make it actually a little bit flatter. So if we look at this one, we've got a number in front, so we would say that this stretches it vertically. Makes it a little bit skinnier, stretches it vertically. And if the number is greater than 1. If the number is between 0 and 1, then we'll see what that does in just a second. So let's try this next one. Oh boy, I gotta move here. So I find my vertex, and my vertex is at opposite sign, same sign. Okay. And my shape equation is 1/2 x squared. So my vertex is at 1, -3, so I'll go 1 down to -3. There's my vertex. And it's the same as the 1/2 x squared. So this is a little bit flatter. There's your shape equation for that we worked out in the previous video. So take a look at that. So I'm going to go over 1, up 1/2. Back 1, up 1/2. Over 2, up 2. Back 2, up 2. And remember on this one we said we could go over to 3 and we go up 4.5. So 1, 2, 3, 4.5. And then back 1, 2, 3, 4.5. And that gives you a little extra point there so you can get a nice idea of the curve, and then we just connect that. Now notice that when we put a 1/2 in front of the parentheses, that's like a is 1/2. When a is like less than 1, it kind of flattens it. And what we could say that it could shrink it vertically or compress it vertically. So this one's stretched vertically, this is compressed vertically or shrunk vertically. Okay, and one more here. So our vertex, opposite sign, so it's going to be -2, same sign 3. And my shape equation is going to be -1/2 x squared. So I'll use that table that we used in the previous video. So I find my vertex, and my vertex is 2 to the left, down 3. -2, 3, opposite sign, same sign. Horizontal shift, vertical shift. And I put my points down, so I'm going to go. Oh, I'm sorry, I got this. I mixed these up. Excuse me. Sorry, I'm kind of hurrying up here because it's running a little bit long. I'm going to left 2, up 3. So my vertex should not be here. Pardon me. Flip these lines, so be careful. Don't make that mistake. I'm going to the left 2, horizontal shift, vertical shift, up 3. There we go. Pardon me. And then I'm going to go over 1, down 1/2, back 1, down 1/2, over 2, down 2, 1, 2, back 2, down 2, and over 3, and I could say down 4.5. Down 4.5, and these are symmetrical. There you go. And then just connect that. So again, horizontal shift, vertical shift, to the left 2, up 3. So there's your new vertex, and then we're using the shape equation. So those are 6 pretty good examples, so you can practice those, and that should give you a pretty good idea of how to find the vertex and how to use the shape equations.